Welcome back to the Algebra 1 videos. This video is dedicated to the concepts of inequalities and compound inequalities. Let's get started. First off, a quick little review. We have 5 different symbols here. These are all inequality symbols that can be used. So let's review what each one of them stands for. The first one, take a look at it. We have an arrow pointing to the left with a line underneath it. Hopefully, you've concluded that this is read as less than or equal to. The second one, equal sign with a slash through it. The slash indicates that it is not equal. The third one, we have an arrow pointing to the right. That is indeed greater than. Very similar to the top, just pointing in the opposite direction, gives us greater than or equal to. And finally, the bottom arrow pointing to the left is simply less than. These are the 5 inequality symbols that we are going to concentrate on for today's lesson. An inequality is simply a mathematical sentence that contains greater than, less than, greater than or equal, less than or equal, or not equal to. Any number that makes an inequality true is a solution to the inequality itself. So here's where you're going to see that your answers definitely look a little different because there is more than one option. However, just simply putting one of the options isn't enough. We're going to need to make sure that we acknowledge every possible solution to the problem. So, easiest way to do that is by using a graph. And in this case, our graph is going to consist of a single number line. So, the first problem here we're told that y is less than 3. So there are a couple of rules that you need to know. First off, for greater than or less than, there is no equal to involved with either of these inequalities. You need to know that you are always going to want to use an open circle to acknowledge that you are not including the number given, but you are going to include everything up to that number. So the fractional parts that get very close to that number are solutions to the problem, just not the number itself. Also, we could have less than or equal or greater than or equal. In this case, you're going to put your circle on the number given. However, now you're going to fill it in. This represents that we are indeed including that number as a solution to the given problem. The last step to graphing an inequality on a number line is to shade all of the other possible numbers that will work. So in this case, because we're referencing the number 3, but there is no equal sign under the inequality, we're going to take our open circle and place it on the 3. The inequality used is less than, so let's take a look at the number line. If I move to the left of our circle, I'm getting the numbers 2, 1, 0, -1. All of those numbers are indeed less than 3. So I'm going to take my arrow that points to the left, and that's the direction I'm going to shade. Most important part is this arrow portion of your shading. That arrow indicates that you keep going to the left. Anything that happens to the left of that number, as far out as you'd like to go, will be a possible solution to the inequality. Okay, let's try some more. In this case, we have t is less than or equal to 8. And again, the hint, a closed circle indicates less than or equal to. Because we are including the 8 as a possible solution, I'm going to take that solid circle and place it on the 8. Again, we have less than, and notice that the less than arrow is also pointing in the same direction we want to be shading. So that is a little trick that you can use as long as the variable comes first in the inequality. If the variable comes first, then you'll always be shading in whatever direction that inequality arrow is pointing. Let's try another. M is greater than or equal to -7. First thing you should notice is the equal to included with your inequality. That definitely means solid circle on your -7. And now this case, the variable's coming first, so my inequality arrow is pointing to the right for greater than. So the numbers that are greater all move to the right. So we're going to shade everything to the right, including our arrow pointing that it would continue on if our number line were longer. We can also be given a problem using words, right? Everybody's favorite, word problems. All right, but these aren't too bad. V is greater than 2. So if you like the inequality symbol better, you can rewrite that. V greater than is our arrow pointing to the right, and a 2. Because we don't have an equal to mentioned, we're going to use our open circle. And greater than points to the right, so we're going to shade to the right. Okay, so that's the basic inequality. Now we're also going to take it one step further and talk about compound inequalities. A compound inequality is a sentence with 2 inequality statements, and it'll be joined either by the word or by the word and. Or means that our solution can satisfy either inequality and would make the entire sentence true. So really what this is talking about is you're going to have to show everything that works for the first inequality given, and you're also going to have to show everything that makes the second inequality correct. And gets a little more particular. If they're connected with the word and, that means that we want to show the solutions that only satisfy both of the given inequalities. One is not enough. So let's take a look at what we're talking about here. In this first problem, we're given that x is less than 2 or x is greater than or equal to 5. And a lot of times what I suggest is if you think of a game, if we have a game where you're going to reach into a basket and draw a random number, and I tell you that you win if you pick a number that's less than 2, or you also win if you pick a number that is greater than or equal to 5. So we want to find out what numbers will make you a winner. So because it's or, we're going to concentrate one at a time. So let's first start with our x is less than 2. In this case, we don't have an equal, so we're going to not include the 2, but we're going to include every number leading up to it. So that should be your first graph of the inequality. So as you can see, you've got quite a few chances to win in that part. Now we need to take a look at our x is greater than or equal to 5, because that's another option for you to win. We have an equal to in this case, so I'm going to put my solid circle, and then I'm going to shade the numbers that are larger than 5. So hopefully you see you've got a very good chance of winning if this is indeed the game, because we've got lots of numbers that satisfy the compound inequality x is less than 2 or x is greater than or equal to 5. Okay, next one. Negative 4 is less than x is less than 7. This is an and problem. If you are not given a word in a problem for a compound inequality, it is always going to be the word and. So we can rewrite that as x is greater than negative 4 and x is less than 7. Because this is the word and, we only want to show the numbers that indeed make both true. So in this case, x is greater than 4, or sorry, x is greater than negative 4, we would put an open circle at the negative 4, and we would begin to shade to the right. For x is less than 7, we would put an open circle on the 7, and we would begin to shade to the left. What you need to recognize here is really we would not go farther than the negative 4 to the left, and we would not go farther than 7 to the right, because we only want to show the numbers that satisfy both, being larger than negative 4 and also smaller than 7. So what you're going to see in the book is really there will be no arrows on that graph. You'll see the end points, and you'll see simply a shaded line in between. This shows all of our options that satisfy both greater than negative 4 and also less than 7. Okay, so let's try one more. Again, this is an and problem because there is no word given. So if we rewrite it as x is greater than or equal to negative 1 and x is less than 5, greater than or equal to negative 1, that's my solid circle, and I would be shading to the right. X is less than 5, that's my open circle, and I would be shading to the left for less than. But again, as I just said in the previous slide, really we wouldn't have any arrows here because we only want what's in between. So I'm going to get rid of those arrows, and I'm going to replace it with my solid line. So we should have our open circle at 5 and our filled in circle at negative 1 shaded in between. Okay, at this point you have had quite a few examples on graphing inequalities and compound inequalities. So here's your chance. Try the homework. If you have questions, bring them to your teacher the next time you're in class, and we'll get you squared away. Good luck, and we'll see you next class.